Bohr atom model. So before that Bohr atom model, so many scientists came. So in that J.J. Thomson is the first person. Next Rutherford came. In the Rutherford it having some drawbacks. So first drawback, that means he does not explain about the stability of the atom, because when the electrons will be revolving around the nucleus, it will loses the energy. So at last it come to the nucleus, and that means fall down to the nucleus. Okay, so only he is not able to explain the stability of the atom. Next, he said that emission of radiation must be the continuous emission spectrum, but our experimentally we get a emission spectrum of line emission spectrum. Okay. So to overcome these drawbacks, Bohr came. So Bohr explained the stability of the atom. In the atom, we know the electrons revolving around the nucleus in the circular orbit under the influence of Coulomb electrostatic force of attraction. So this Coulomb's force will be the necessary centripetal force for the electron to undergo the circular motion. So electrons revolving around the nucleus only in the certain discrete orbit. So it is called as a stationary orbit. So electron revolving around in this orbit does not radiate the electromagnetic energy. Only those discrete orbits are allowed. It is called as the stationary orbits. So the angular momentum of this electron in these stationary orbits are quantized. So it can be written as the integral multiples of h by 2 pi. We are simply saying as the h is the Planck constant. Okay. So angular momentum L is equal to n h cross, where h cross is equal to h by 2 pi. It is called as the angular momentum quantization condition. According to the quantum mechanics, we know the particles, that means it's like electrons, have the dual nature. So the circumference of the electron's orbit with a radius r, it must be the integral multiples of de Broglie wavelength. That means 2 pi r is equal to n lambda. N is the integral multiple, lambda is the wavelength. But the de Broglie wavelength of an electron, we know lambda is equal to h by mv. So from this equation, that means 2 pi r is equal to n lambda, we can write 2 pi r is equal to n into h by mv. From this we can write mvr is equal to n into h by 2 pi. For any particle, it having the mass m, it moving in the circular motion with the radius r, with the velocity v. So magnitude of the angular momentum, we know L is equal to mvr. So mvr is equal to L, it is equal to n h cross. That means n into h by. Energy of the orbits are not a continuous, it is discrete. It is called as a quantization of energy. An electron can jump from the one orbit to another orbit by absorbing or emitting the photon energy. So the energy variation between these two orbits, or we can write del E is equal to energy in the final orbit, that means last orbit, E final minus E initial, that will be equal to h nu. We know the general formula E is equal to h nu. From that we can write energy difference between these two orbits, del E is equal to E final minus E initial will be equal to h nu. We know the nu is equal to c by lambda, so h is c by lambda. Here c is the velocity of the light, lambda is the wavelength of the radiation used, and nu is the frequency of the radiation. So the frequency of the radiation is emitted, it will be related to only the change in atomic energy, that is del E. So this frequency does not depends on the frequency of the electron's orbital motion. It only depends upon the wavelength. So difference in energy will be depends upon the wavelength alone.